synthesis.
Hello everyone, my name is Bryson Belzer and this is my project called Engineering Synthesis. So an overview, we're going to talk about what is modular synthesis, we're going to talk about the modules I end up building, and we're going to reflect on it and talk a little bit about a future project. So an introduction to modular synthesis. Do you guys know what a synthesizer is? You've heard music. It's an electronic music device, kind of thought of as like a piano, except you're generating the waveforms rather than using samples or actually striking strings to make music. So, alright. I've had some music projects in the past, like I work with music, and this is one of my songs, Oedipus Rex, and I use GarageBand to produce my music, and the video is not going to load.
Hang on 1 second, I think we lost connection. Excuse me 1 second, guys. I just noticed my phone disconnected. My apologies. Should be.
So now the video will work.
Okay.
So I do a lot of electronic music already, and I wanted the physical versions of what I was tapping on my phone. So this is what I made with my phone, or a snippet of it, because the whole thing is So that's the type of music that I end up making, and you'll hear some more of that later. Alright, so I had some SAE goals for this project because it is an SAE project. I want to explore interests in my career. So I want to be an engineer, but I don't want to build bombs like all the other engineers. I want to make music because music is more fun than bombs. Identifying new technologies. So I work with different VCOs, different types of chips, all sorts of electrical engineering concepts, and developing those career and technical skills like good wire management, knowledge about the mathematics behind this sort of stuff. And this is my first working oscillator, playing Yankee Doodle, the official song of Connecticut, because Connecticut's cool. And that's the code that's making the sequencer work. That was in like October too. And this is the first thing I ever got a sound out of, which was a function generator on like a $20 oscilloscope I got off of Amazon. And it's not the most pleasant sound, but it was the first thing I got a sound out of. I think that was an old speaker I took out of a keyboard that I didn't like. So the next thing I moved on to after I built that VCO and stuff like that was I needed a bit more power behind my sequencer so I could do stuff live. You know, like right now on the sequencer I have here, I have a knob to do some beat matching so that we can, like a DJ would, and you can type in sequences live so you have some a human element to electronic music. So the first thing I thought of that had more processing power than an Arduino was a whole computer. So this is a Windows 2000 computer, and I used C++ to, well, I learned some C++, which is on the right. I made the Hangman game, and on the left there, I programmed the parallel port using inline assembly, and it was pretty like rough process because it wasn't made to do that. And so I moved on. This is my grandfather's TRS-80 that I also worked on during this time. It was just learning more about older computers, because older computers, you can see all the chips. Like on your modern computer, you can't see all those chips. You can see what each one is, and you can kind of tell what it's doing, and that's why I started with really old stuff. We'll get into some more really old stuff. And these are some of the schematics for the oscillator. So this is the old stuff I said we'll get into. My second sequencer was based on an 8088, which is a microprocessor from the 1970s, and I programmed it in, like, this is an example of assembly language, and this was a worse process almost, because you had to build a whole computer. So like this is the central processing unit. This is the random access. No, sorry, that's the read-only memory. This here is the random access memory that wasn't added yet. And then there's like gates to shift stuff out. And it's so much work to just even get a system going, never mind a sequencer. So I never went too far with that, but I did build my own assembler, which is the thing on the right. It takes the assembly code and formats it into a hex dump. So I built that in Bash, which is a programming language. And this is the 8088 system starting up. There's no audio, but the LEDs indicate the address and data buses. So that's good for troubleshooting. Alright, so let's get into the more musical stuff. This is version 1 of my VCO, and it had an integrated filter, so filters kind of like shape the type of sound you're hearing. It output a reverse sawtooth wave, which also has a certain type of sound. And it had proper volt per octave tracking, which is important because in modular synthesis you want to be able to take an output from any sequencer, and they use what's called the volt per octave standard. So la la, that's an octave, and that would be a 1 volt difference in control voltage. So this was an example of that running. The song Echoes by Pink Floyd, sped up like 1 billion times. And I'm adjusting the filter and the actual playback speed in this video. So this is a picture of the VCO which I was using in that video. On the bottom here is the power supply. You can see the transformer. These are voltage regulators. This is where the music is actually being generated. This is middle board. And then up here is what's telling it what notes to play. The black thing and the other thing. And then on the right, it's the same thing. So, what was my research process like? I looked at Maritz Klein's videos, were very helpful. It was building a DIY VCO, but I didn't like his VCO. I didn't want to use that exact design because it had not a square wave output. So with a square wave output, you can filter it basically into any type of sound that you want, and it required a lot of components that were pretty expensive. So I went for a simpler design. So VCO V4 is where I do my own demonstration. I'm gonna just take this out. Because this is VCO V4. So right now it's playing the sequence. Sadly, we don't have that much time for the whole song. So it had simpler components. It had interface. Now that I'm done with the demo, I feel comfortable taking all these wires out, and I can pass this box around if you guys want to see. So that's my VCO. Don't drop it. It's a bit less expensive than Maritz Klein's is, and it's still not a square wave output. You can't get them all. This was a video in case that didn't work. This is the version 1 of the sequencer, which I explained a bit of earlier, and it's a similar design to what I have today. Version 2 was a little bit crazy because I was building an entire computer, and I did build the entire computer, I just never made an operating system. for it, because that would have taken forever. And I was running out of time. By then it might have been like not May, March. Sorry, March, May, very different.
Question? You got about 30 seconds.
This is the third version of the sequencer. This is the wave shaper, which is part of the modules. The power supply I rebuilt the most number of times because I kept having issues where like all the voltage would go to the negative rail and then the op amp would catch on fire, and that wasn't really fun and it would make noise. So setbacks were the monetary, the ROV team took up a lot of my time, as well as chemistry. The takeaways were the values of neat wiring. Like you could see in the computer, I spent a lot of time making sure the wires were very nice. And my community outreach included, I went to John Winthrop Elementary School here. And I taught a bunch of, I think, 7th and 8th graders about how to like count in binary on your fingers and stuff like that, which was a lot of fun. And then over the summer, I plan on expanding it, making it Eurorack, which is a nicer module, not a cardboard box. And I soldered the power supply, and I'd like to acknowledge David Blow for being a great mentor, Alicia Cook for helping me find resources all across the state, the Sound School community for their support, my Uncle Tony and Uncle Brian for helping out with the engineering and project management side, my sister for taking pictures, and my mother for always supporting me, my grandfather for letting me borrow his TS-80, Maurice Klein, and Ben Eater and Slater UK for having great YouTube videos, and the Sound School PAC for hosting this. Thank you so much. And these are my
Okay. Questions for Russia?
How do you even know that you're interested in this? Did you feel like, what is it that gets your brain going here with this?
So I always liked music, like when I was like 3, I had a keyboard, and I loved playing around with it. And you spend enough time on YouTube, you'll see a lot of people doing a lot of cool things, and you'll find your niche.
What are your next steps after this?
So my next steps, we can go back to the slide to look at it. I want to make a module, like a bit of a bigger box, maybe with like a wooden frame, and then integrated into the box will be the sequencer with buttons so that I can play live. My sequence was pre-programmed today because I just wanted it to work. And then I'll have my VCO module, which is, I don't know if I ever said, it stands for voltage controlled oscillator, so it's the thing that makes the sound. And that'll have all the knobs and inputs and outputs and such to make it work. So those are my next steps.
All right, thank you.